Arvind, today's topic we are going to see.
Mhm.
Let me come here.
Okay.
Today we are going to see the GRE, okay, generic routing encapsulation. Let me come on there. Today's topic we have GRE, that is mine. Generic routing encapsulation, that is route based. We have seen, remember, do you remember? Route based and policy based. This will be your route based VPN. You mute your site, route based VPN. Generic routing encapsulation is a protocol. I'm writing some points here. Generic routing encapsulation, that is GRE, is a protocol that is encapsulates packets, that is encapsulates packets in order to route. I told you that is route based. That's why in order to route other protocol over IP network.
Hello.
Yeah, over IP networks. GRE is defined by RFC. I'm giving you here. RFC I'm giving you here for GRE. GRE is defined by
Hello.
yeah. Are you getting me? RFC.
Yeah, yeah.
RFC.
It got disconnected multiple times.
Okay. 2784.
Hmm.
2784. This is the RFC. You can refer it to get more knowledge on that of the GRE points. Okay. So I'm coming on
Okay.
at some points I'm writing here. GRE based on
Hmm.
IP based protocol. Write some points here for the theory part.
Okay.
GRE is IP based protocol with protocol number 47. Number 47 works based on VTI. Works based on virtual tunnel interface, that is your VTI, or it's also called as logical tunnel. We will see inside the lab.
Mm-hmm.
Logical tunnel. Okay, done up to here.
Okay. 1 second. Yeah, done.
Okay. right from here. Virtual tunnel interface, when we will create a VTI, that is virtual tunnel interface on both sides, right? It is peer-to-peer, so on both sides should be in the same network. Should be in the same network. Okay, very important points, this one. Next is telling you data and private source and destination. Data with private source and destination IP is encapsulated with GRE protocol. GRE protocol and add public source and destination IP. Add public source and destination IP to route over internet. Okay, let's come on the lab part. We will see here. The lab is like this way. Then this way.
Yeah, this is done.
Okay, see here. The lab will be like this way. This is my R1 router. This is my R2, and this is my R3. All are connected with each other. Here, the network will be F0/0. That is dot 1. This is my F0/0. That is dot 2. This is my F0/1. And this is my F0/0. The network is here. We have, I'll use here, the network is 1.1.1.0 with the subnet is 24. And my loop back, this is going inside the tunnel. That is mine. That is the client. You can say here. That is loop back 1. And it will be 192.168.1.1, 192.168.1.1/24. And I told you, like, we will create a VTI tunnel, right? Tunnel interface, virtual tunnel interface. So the virtual,
So it's same network should be
yeah,
there.
should be in the same network. Virtual tunnel INT I have written, interface should be in the same network. So I'm writing here that will be 10.11.1 or 0 network you can take, but I'm giving the IP address of the virtual tunnel interface, that is 10.11.1/24. Clear? Here I have the network. I'll be using the network here. That will be mine here. That is my dot 2 from this network. That is the network is 2.2.2.0/24. This becomes my dot 3. Okay, and here I'll be use the network. The loopback here I'll be use interface loopback 1. That is my client. So it becomes loopback 1 will be mine 172.163.3, 172.16.3.3/24, and tunnel interface external interface from the same network, I'll be using here 10.11.11.3. 10.11.11.3/20.
Mm-hmm.
Fine. This is your topology.
Yeah.
We'll do the topology. I'm coming on the notepad. First, you draw this topology.
Done. Done.
Done? Okay. Okay. I'm coming on the
Yeah.
notepad. Writing here. Then the configuration is will be right on the R1. I'll be on R1 here.
Mm-hmm.
Enable configuration terminal interface is F0/0. IP address is my 1.1.1.1 255.255.0. No shutdown exit. IP route I will use here with 1.1.1.2 R2 1.1.1.2. Correct? Then after I have the loopback is there interface loopback 1. That IP address of my loopback is 192.168.1.1 192.168.1 255 exit. This is my R1 configuration. I'll become on the R2. Right on R2 configuration. Inside R2 we have here configuration terminal with the 0/0. IP address is my 1.1.1.2 55 55 55.0 no share exit. Then after I'll be other side interface 1 IP address is 2.2.55 255.0 no shut exit. And the basic configuration I'm giving here. Then after I'll be on the R3.
Mm-hmm.
On R3 that configuration becomes configuration terminal into F0/0 and my IP address is 2.2.2.3 255. This is R3. That's why I use 3. 55 255.0 shut down exit from here. I'll use the route for that. That should be I'll be able to reach to the R1. So I'll be write the route. IP route is my 0 sorry 0.0 oh, here 0.0.0.0 with 0.0.0.0 and my gateway becomes 2.2.2.2 R2. Then I have the loopback is there. I'll use the loopback form. IP address I will use here that is 172.60.3 255 55 255.0. Then after I'll be exit from here. Right? This is my basic configuration I have done. Then after verification you have to do so. Is my ping from R1 to ping reachability you have to check 2.2.3. That is true for R3, right? Then after I'm coming here and starting our that GRE protocol, okay? So what is happening?
Okay.
First thing we are doing here, concept is GRE no GRE without IPsec. That means it is not secure. You understand my point? We are creating only
Yeah.
one tunnel. So GRE without IPsec,
Mm.
I'm going coming here. That is between R1 and R3. Okay, so I will come on the R1. On R1, I'm writing the GRE protocol here. I'll be used here. That is virtual tunnel. You remember? So I'll be used interface tunnel 1. Okay, and for that tunnel, I'll be use the IP address. That will be in the same name. IP address is my 10.11.1 255
Mm.
dot 55.55.0 and tunnel source from public IP. Tunnel source is mine 1.1.1.1 and tunnel destination is mine destination is my R3, that is 2.2.3. Then also I'll be exit from here and we exit, and what is happening? See here, this is my R1. Okay, just see. I told you I'll be create here. I'll be create here the tunnel. That is my virtual tunnel. That is called VTI.
Yeah.
Virtual tunnel interface. Okay, and that for the virtual tunnel interface, I have the same network I will be used. Same network. That network is my 10.11.11.0 network. Clear? Then after this
Mm.
source is my public IP from where my interface will be open. Public IP. That means you can find here this one. Sorry. This one. This public IP. That is 1.1.1.1 and destination is
Mm-hmm.
2.2.2.3. Clear? So what
Mm.
I did here,
Mm.
tunnel is this one and destination is becomes my this one. This is source public IP and this is my source and this is my destination public IP. But this is it. This is my tunnel. This is the tunnel
Mm.
IP. Clear? Understood my point?
Okay.
That is
Okay.
the tunnel. See here. That is the tunnel IP. This is the tunnel IP address. This is the tunnel IP
Mm-hmm.
address. It will be in the same network. That means 10.11.11.1 and this is 10.11.11.3. Okay, but it will be start from
Mm.
the R1 to R3. Correct or not? This is my
Mm.
R3 and this is my R1. So I have to give here the source part because this is route based. In place of your ACL, understood? We are creating
Mm.
a routing
Mm.
table, route based KPL. Create one route, that is the route. It is completely known as route. That's why I written inside the theory also. Route. Right now it's clear?
Mm. Mm.
Okay. This is my R1 part is done. Then after I will come here. I'll be come on the R3. On the R3 type right here. You should write interface tunnel 1. Interface tunnel 1. Okay. Then after the IP address is my 10.11.11.3. Same network, correct? 255.255.255.0 channel source, just vice versa. resources becomes my 2.2.2.3, and tunnel destination is becomes my 1.1.1. Clear?
Yeah.
I'll be accept here, and then after this is my basic configuration I have done. Okay. Then after what I will do inside the verification part, what should you have to do here from the R1 is you have to ping 10.11.11.3 with source tunnel 1. That is my R1. Okay. Tunnel 1. That means from 10.11.11.1. Then after you have to check here if you want to check inside the R1 the information about the tunnel. The command you have to use here for that purpose. The command is show interface interface tunnel 1. It will give you the information about your tunnel, which tunnel you are using. All like know that route your 10.11 dot and how that tunnel is going through that. Okay. Now what we'll do here after this completing, my tunnel is not secure. Okay, and I have not advertised my private IP addresses here also. My private IP addresses is my loopbacks. Clear my point? That is not I have all inside my tunnel. That only the basics tunnel I have created here. For that purpose, what I'll be use that now I'm writing the command, now writing the next step here that now use I'll be use here the EIGRP. Okay, in the EIGRP, what I'll be use here now, note I'm writing, only private IP addresses are added in the routing protocol. Only private IP addresses are added added in the routing protocol. Fine. So what I will do here, I'm writing here on R1 again. I'll become on R1. And I'm writing here route EIGRP 10 router EIGRP 10. Then after network, we have two networks is there. Both are the private networks. Okay. So one network is mine 10.10.0 and other network is my loopback, that is 192.168.1.0 192.168.1.0. Fine. These two networks I have advertised with the help of EIGRP. Then after I'll become on R3. On R3 I reach and then after I'll be using interface tunnel 1 interface tunnel 1. Then after IP address is mine here. Sorry. This is interface not tunnel router EIGRP 10 router EIGRP 10 and then after I'll be network is my 10.11.10.0. Other network I'll be used here 172 network 172.16, that is the client, right? 172.16.0.0 and then after I'll be exit from here. Fine. What you will get, I'm writing here some points under the note again. If you do it this part, EIGRP never will come up. Okay, EIGRP neighbor will come up. Fine. Then after what you will do, verification for that. where you can do ping from R1. Okay, in here from R1, what you have to do, you have to ping ping that client address, that is 22.60.3.3 with source loopback 1. Source loopback 1. Fine.
Okay.
Then after, what you have to check here in the R1, you should check here. So IP EIGRP neighbors. So IP EIGRP, it will show you
Hmm.
neighbors. Okay.
Yeah.
So what you will get here, that
Mm-hmm.
you will find after that you can go and capture the packets. Okay. Under note I'm right.
Okay.
Right. Go capture packet in where? What's what you will get here, that the private information is also replicate. Your
Mm-hmm.
private. What's the private? Your loopbacks. Loopbacks is also replicate cipher packet. Okay. That should not come because the private information should not come on the public, because anyone can get
Hmm.
information about that. So after using of that part, so what you will do now, you will check your that protocol, you will find here what you will get there inside. When you will check inside the your Wireshark, you will find here. Now let's check data. I'm writing points. So let's check data part passing through tunnel where type will find IP. IP will
Mm-hmm.
be, it is 0 into that the multiplication of 0800. 0800. That means it will show you indicates about IPv4 header. Indicates
Okay.
about IP version 4 header. First, next you should write here. Next you will get protocol.
Mm-hmm.
Protocol will see here, that will be GRE, that is my 47, indicates about GRE header.
Hmm.
Header, right? Next you should find here protocol of ICM. So you're pinging right now. Protocol
Yeah.
will be ICMP. That is inside your inside your Wireshark. Okay, that will be
Yeah.
one. One information I am giving you indicates about ICMP header.
Hmm.
Indicates ICMP header.
Hmm.
That you will get your inside your Wireshark. That means your packet is proper. That the proper packet is going from the one tunnel to other tunnel. Understood? Next point, what we will do here, next you should come here and I will show you GRE adds under the notes continuous GRE and the star I am writing this
Mm-hmm.
GRE add a new GRE header, GRE add new GRE header, sorry, new GRE header to the existing packets. Packets, the original packets is carried.
Mm-hmm.
Carried through the IP network and only the new outer router and the new outer header is used for forwarding. Once the GRE packet reaches the end of the GRE tunnel,
Mm-hmm.
once the GRE packet reaches the GRE tunnel, the external header is removed. Very important. Maybe this is questions will become for your interview. Okay. So the header,
Okay.
external header is removed. Just a minute. Just a minute.
Yeah, yeah.
Hello.
Yes, sir.
Yeah, that is header is removed. Header is removed.
Mm-hmm.
Yeah. And the internal packet is again exposed. And the internal packet is again exposed here. That means if you are using this GRE, understood or not? Points.
Mm-hmm. Mm-hmm.
Right. This is not safe here. Clear. So what is happening again? These packets will be so that your private packets because it is showing only the.
Okay.
So for that purpose, what we will do? We are coming here And one more point here, this is for your GRE, and we will write the ICMP is also there, right? Because we are bringing from the one tunnel to another tunnel. So for the ICMP, I'm writing here. So right here we can use see the ICMP packets, right? Here
Mm-hmm.
we can, because through the ICMP only we have to establish that the tunnel between the one source to other destination, or from the other part to other part,
Mm.
right? So here we can see
Mm.
ICMP packets, comma, private IP, private IP. What is the private IP? That means your tunnel IP and
Yeah.
your source loopback, right? That is your
Source and destination. Yeah.
yeah. Private IP and GRE information and
Mm-hmm.
GRE information, GRE information, which which means tunnel is not secure. Which means tunnel. I already told tunnel is not secure because I have to use the
Mm.
IP secure, which means tunnel is not secure. So we need to use. So we need to use IPsec to encrypt above, IPsec to encrypt above information and secure the tunnel. Information and secure